Welcome back. Today, we are going to calculate the running time complexity for the quicksort algorithm. Before continuing, I would suggest you to watch the previous parts of quicksort algorithm for better clarity. So let's start. This was our code for the quicksort algorithm. Now to find out the running time complexity, we have to create a recurrence relation first. To move forward, we have to calculate the running time complexity for partition algorithm first. If there are n elements present in the array and we pivot the last element, so the leftover elements will be equal to n minus 1 pivoted element, so the comparisons done will be n minus 1. So our running time complexity for partition algorithm comes out to be big O of n minus 1. Since we assume input n as an infinite number, therefore complexity will be equal to big O of n. Now the complexity for quicksort for right part and left part of the array will depend on how the elements are divided after partition algorithm. Let's take a scenario in which pivoted element comes to a correct position at index 2 here in this case. And on the right part of the pivoted element there will be n, which is total elements, minus elements on the left of the pivoted element, which is k here, minus 1 element, which is here itself, pivoted element. Total elements present on the right part comes out as n minus k minus 1. If we assume time taken by the quicksort function for the left part elements as a function of t as k elements input in it, and for the right part of the array as in minus k minus 1 input in it. Our general recurrence relation will come as a function of t with k input in it, plus function of t as a n minus k minus 1 input in it, plus the running time complexity for partition algorithm, which is big O of n. Now for the worst case complexity, suppose the pivoted element comes to a particular index from where there is 0 element present on its left part and remaining elements on the right part of it, which will be n minus 1 elements. In worst case, each time the elements will be divided in this manner, such that there is no element present on its left side, and remaining elements are present on its right side. So here, every time, quicksort have to work on the right side elements of the pivoted element, which is in minus 1 elements, because there is no element to work on at left part of the pivoted element. Now, here, value of k becomes 0 each time after applying partition algorithm. To find out the running time complexity for worst case, either we have to solve this recurrence relation, or we can just find the height of this tree. After solving either of the two, we get our worst case complexity as big O of n square. Now to find out the best case complexity, we have to make an assumption that the elements after execution of partition algorithm divides in such a way that the number of the elements present on the right side is same as the number of the elements present on left side. Here, each time quicksort will performed for the both sides of the pivoted element. Every time the input is halved. So the value of k becomes n divided by 2. We can also observe from this tree that the first input was n, and in next stage, it becomes half, and in another next stage, this becomes half of the previous input, and in this way, each time the value will be halved, so we will replace the value of k with n by 2, wherever is k present, in our general recurrence relation. We can solve either this recurrence relation or find the height of this tree. To find out the complexity for the best case scenario, here I will prefer to find out the height of tree rather than solving above recurrence relation. The height of tree comes out to be log n to the base 2. Here the base of log tells us about how many times the problem is divided in half. Here it is 2, so we wrote base 2. Here the complexity for the best case comes out to be sigma of log n. for finding out the running time complexity in average case is a bit difficult. Here, we cannot find the proper index at which the pivoted element will be placed. So, we have to take various cases into consideration, and then we can average all the possible cases out there. At first, we will suppose that the elements are divided in such a way that on the left of pivoted element, there is 0 element present, and on the right side, there are n-1 elements present. This is also the case we took for finding out the worst case complexity. Then we can assume that there is 1 element present on the left side of the pivoted element and n-2 on the right side. In this manner, we can make all the possible cases out there. Our last case would be at when there are n-1 elements present on the left part from the pivoted element and 0 element on the right part of the pivoted element. Now we will form recurrence relation for these cases by just putting the value of k in our general relation. For first case value of k is 0, then 1, then 2, and at last the value of k will be -1. After forming recurrence relations for all the possible cases, we will add up all the cases and we'll try to find out the resulting sum. Here, sum of big O of n is repeating n times, so its sum will be n times big O of n. To find out the sum of these terms, we will rearrange these terms first. Here we can observe that every term is repeating twice, so our sum will come out to be twice of these series of terms. Now here, to find out the average, we will divide this by the total number of possible cases, which is here, n. We can take 2 divided by n out, and we will be left with the sum of series of term, plus big O of n, because n got cancelled with n which is outside. Now we will form a general term for this series by adding sigma function with variable I starting from 0 and ending at n. Inside it, we can write function of t as I argument in it, adding up to the function t as I-1 argument in it, forming the same series which is written above after solving, and plus the time complexity for the partition algorithm. On further solving it, we get our answer as n times log n. So our running time complexity for average case comes as theta of n log n. In this way, the calculation is made for finding out the running time complexities for quicksort algorithm. That is it for today's video. Meet you in my next upcoming video. Till then, keep grinding.